Hello. Today we're going to be talking about the topic in Math 112, Calculus 2, integration by parts. Integration by parts is a very common integration technique, and it's probably one of the most important things that you're going to be learning in Calculus 2 because it has a wide variety in all sorts of applications in many branches of mathematics. So we begin our discussion by looking at this integral, the integral of x times e to the x dx. So far, you've only learned u substitution as techniques for integrals. So let's see if we can solve this with a u sub. So let's say u is equal to x, because we have this x here. That might make sense. Our du is then equal to 1, which means our integral then becomes the integral of u, because it's x, e to the u du. Well, that's a problem because we just ended up back where we started. And it turns out that there is no clever u substitution for this integral. U subs cannot solve it. So we need a different method. And that's where integration by parts comes in. So we're going to start by doing a very quick derivation because integration by parts is a very easy to derive formula. So we're going to start by saying, imagine we have two functions. Well, let's write it over here. Say we have two functions of x, f of x, and g of x. And what we want to do is we want to take their derivative, their derivative of their product. So let's multiply f times g, and then let's take the derivative of this. So let's take the derivative of f times g. Well, that gets us, from the product rule, the derivative of f times g plus the derivative of g times f. Right? This is a material that you learned in Calculus 1. It shouldn't be too unfamiliar. But what we're going to do is we are going to integrate both sides of this equation. So let's integrate this with respect to dx, and let's integrate this with respect to dx. So what we do is and we can break this integral up because an integral of sums is just the sum of the integrals. And this right here, let me get a different marker. This right here, so much better, just cancels out because the integral of a derivative is just the function itself. So what we end up with is f times g is equal to the integral of f prime times g dx plus the integral of f times g prime dx. So from here, it may not seem like we've done anything useful, but let's move this over to this side by subtracting it out. And let's write this whole equation for this. So we eventually end up with our new formula is the integral of f times g prime dx is equal to f of x times g minus f prime times g dx. And this, funny enough, is actually our integration by parts formula. It was really easy to get to, very fast. And let's just take another color and we'll make a very quick substitution so that you can get this into the form that you're probably going to be used to with your professors. And we'll write it up here. So let's just say that u is going to be equal to f of x. We're going to say v is equal to g of x. And then du is going to be f of x prime times d of x from the chain rule. We're going to say dv is equal to g prime times dx. This is just a substitution, just so we can change the variable names up a little bit. But if we perform this substitution on this formula right here, we will get what you'll probably see about 100 times in a textbook, and I'm going to write it up here so we can leave it. You will get that the integral of u dv is equal to uv minus the integral of v du. That's a u. So you may be wondering, and actually I think I might have wrote this a little too high. Let me just move it down a little bit. Integral of u dv is equal to uv minus v du. There we go. That should be a little bit better. So what makes this so good? Well, it may not be very obvious when you first look at it, but what this formula is doing is it's taking derivatives from one function and it's moving that derivative almost over to the other function. So we're performing a bit of a swap. So if one function is very easy to take derivatives and it will eventually vanish, whereas the other function is very easy to integrate, we can actually find ourselves with much easier integrals to solve. So I'm going to erase the board, and this might be apparent in our next example. We're going to solve this problem. OK, so now we're going to work, and we're going to finally solve this integral. So using integration by parts, the first thing we need to do is we need to choose our u, and we need to choose our v. So our u is going to be something that is easy to take the derivative of, or reduces when you differentiate. So we say reduces when you differentiate. Or let's say easy derivative might be a better term. Easy derivative. And then v is going to be something that has an easy integral. So in this case, if we take the derivative of x, well, let's say u is equal to x, the derivative of u is just equal to 1. So that's easy. We just reduced our function u down to just a constant, which is really nice. And if we then say that v is e to the x, then our dv, because in this case we're working with this right-hand side, so our dv is e to the x. If we integrate that and get its antiderivative, we just end up with e to the x again. Now we plug into the formula. The first part is u times v. So I like to draw this little triangle when I do it. So u times v, it's x e to the x minus du times v, because that's what we get right here, minus the integral of v, we'll say first, times du, and then dx. And now we have this right here, and this integral is easy to solve, because this is just the integral of e to the x, which is a very common integral. We see it all the time. So if we bring this out, we get x e to the x minus e to the x. And since this is our final integral, we add the plus c to the end. And that is the integral of x e to the x. It's not too particularly difficult. You just got to remember the form, and you just have to make a good choice about which functions you're going to have for your u and your v. And in our next video, we're going to be going over 2 more examples of integration by parts, and hopefully with those it should become even more clear when are some good examples of u's to choose and v's to choose. All right, thank you.